Now we want to fill out our number circle for sign magnitude. Um, so that means that anything, the way sign magnitude works is anything with a 0 as the most significant bit is going to be positive. So we kind of have, I'll make a little divider line here just kind of for our reference, right? We've got everything here is neg, and everything here is positive. I'm doing it kind of in a hard to see color because it's not necessarily part of the number circle, but just there, just for our information. So the way this works is the 0 bit, or the most significant bit, tells us our sign. Oh, sorry, I wrote that the wrong way, didn't I? Hopefully you caught that right. This is negative. This is positive. There we go. That's better. So this 0 represents a positive number, and then the other 3 bits, the least significant 3 bits, tell us our value, right, or our magnitude. So this is just a 0. This is a 1. This is a 2. This is a 3, 4, 5, 6, and 7. And then we've got this guy here. This is a negative value, but the magnitude is still 0. So I guess we could kind of say negative 0, which is just the same as 0, right? 0 doesn't really have a sign. Then this is negative 1, negative 2, negative 3, that's bad 3, negative 4, negative 5, negative 6, and negative 7. And now we want to go through and ask ourselves if we have these properties. So first we have to say, do we have a single 0? Well, we have a 0 here, and we have a 0 here. Even though it's negative, I mean, once again, they don't really have signs, right? Zeros don't really have signs. Negative equals positive for 0. So we don't have a single 0. We have 2 zeros. So we're going to put a big no there. Do we have a clean 0? Well, the way I always say it is if we don't have a single 0, then we couldn't have a clean 0. We do have a clean 0, but we also have an unclean 0. So there's 2 ways to represent 0, right? We could say 0 is represented with 0, 0, 0, 0, or we could say it's represented with 1, 0, 0, 0. And this is not a clean sequence, right? A clean 0 means that it's all zeros, and this is not all zeros. So I'm going to say no here. What about a unidirectional increase? Well, let's count around here. So we're going to start at our minimum. 0, 1, 2, 3, 4, 5, 6, 7, and then we bounce down to all the way to 0, and then negative 1, negative 2. So now we're decreasing. So this looks like it is not a unidirectional increase. A clean rollover. So clean rollover, what we just look for is if our max is next to our minimum. And it looks like our max is here and our minimum is here. So they are pretty much as far away as possible. So we don't have a clean rollover. And what about a full range? Do we have a full range of values? Well, let's just count how many unique values you have. So 0, so we got 1, 2, 3, 4, 5, 6, 7, 8. Don't count the 0 again. 9, 10, 11, 12, 13, 14, 15. But we've got 16 sequences here. So that means that we've got 15 values represented by 16 sequences. So we're not utilizing that. We could have another unique thing there possibly. So it turns out that sign magnitude has no desirable properties in terms of being able to do mathematics handily. That's what these properties are really here for, is if we have them, it's easier to do math and functions with them. So it turns out sign magnitude is not that useful for a lot of things.